Okay, so you all noticed when you went back to the week 1, class 1 module that we posted last week's recording, and we did it that day. So we'll always do that, so you could always go back and re-listen to our lecture. So right now I'm in my dashboard, and you could see that I have a hell of a lot of stuff in here. Okay. What I want to point out first is take a look at the engineering student. Everyone should look at their own page, and you should have engineering student now. And I'm going to click on it, and I'm going to open it up in there. I'm opening it up. And if I go to announcements, so this engineering student Canvas page has nothing to do with our course. It's a way that all engineering faculty and STEM counselors can post things of interest for you. So notice we post scholarships. We're posting how you could get a Cabrillo email. We're posting more scholarships. There's a conference coming up in biomedical engineering, internships, emergency funds, mentoring. So there's a whole bunch of things in here. I'm going to stop sharing for a moment. So the fact that you have access to this engineering student is because you are an engineering major and taking an engineering class at Cabrillo. So you should set up your Canvas page so you get all the announcements to your phone in some manner, whether you want to do it through Canvas or you want to get an email. But it's really important for you to get all the announcements so that you know what scholarships are out there, internships, conferences, etc., that you could participate in. Everybody got that? Everybody understand? Okay. I'm going to go back to sharing now. And I'm going to go back to my dashboard. So you should have the engineering student Canvas page as well as your courses. So right now I'm going to the engineering 5 course because that's what we're in. And the first thing I want to do is I want to go to our last week's module. Actually, you know what I'm going to do first? Yeah, I'm going to go to last week's module. So I'm going to close these for now. And this screen probably looks a little different on your page than on mine because I'm in the instructor view, but certainly you have similar stuff. So for class 1, the homework that you did is you did the homework 1, you did the quiz associated with homework 1, and you did discussion. And I just want to open this up for a moment. By and large, everybody was fine. There were some things that were a little problematic, so I just wanted to address them. Make sure that you do read the full homework assignment because the first one was to read, and then B, C, and D were asking you to do things and write things for us. And some people did D, the time management table, but didn't answer the question. So make sure that you're really reading through this and answering everything that you need to. You'll also notice that at the bottom of each homework assignment, there's always a rubric. And when we do grade it, we grade it according to this rubric. So when you look at your grades, you could see that 4 of the points went to B, 4 of the points went to C, 2 points went to D, and then we graded you accordingly so you knew what you missed. In addition, in the homework, you'll see comments. And Pretty or I, depending on who is actually grading it, this happened to be homework 1 I graded, I write comments in the comment field so that you know what it is that I was looking for, or I'm commenting on something that you wrote. One thing that is important is I want to make sure that from now on, you actually do only submit one file, because it takes a while to download the files, and I only want to be looking at one file. So you'll notice in the future homeworks, at the bottom of the homework, it now says submit as one file. Okay, so now just after reading everybody's comments, I wanted to make a couple of comments myself that were general. In the first, in the attributes, a number of you wrote attributes that you want to get, which happen to do with understanding engineering globally, understanding engineering ethics, getting technical skills. And you are going to start to get those skills in this course. So we're going to be talking about global engineering and industries, and we're going to be talking about engineering ethics and social justice and engineering. And you're also going to start getting some engineering skills in this course. And then as you move on to the other engineering courses in Cabrillo, you're going to be getting more skills. So it was neat to see that a lot of you said that these were attributes I plan on working on, and you will get some in this class. Then, as far as the time management, I noticed there was a lot of you wrote a lot of the same time wasters, and most of it was around technology. Using social media too much, using YouTube too much, texting too much. And it was good to see that you're starting to realize things that where you're wasting time and how you can make changes in your behavior to really follow in what you actually want to do. Some of you also wrote that you were overcommitted and you have a hard time saying no. Like sometimes your boss will ask you to work extra hours. Yeah, you have to figure out by making up your schedule what your needs are and make sure that you're committing to what your goals are. That's the main idea. And then you have to say no at times. I have to do that as well. I tend to be someone who wants to do a lot of things at Cabrillo, and I have to cut back because my priorities are my students. And then a number of you also mentioned something about sleep, and I know you know how important sleep is. So make sure you're getting enough sleep for your body. Another thing that some people mentioned, I believe it was up in the goals, was how it's really important that they help their family. And that's something that they want to do as they move through the engineering curriculum, but more so when they graduate. I want to also let you know that at Cabrillo in the engineering department, we consider engineering a helping profession. So you're going to learn as you go through the courses, and if you're part of engineering abroad, that you could use your engineering degree not just to help your family, but also to help your community where you live and also help global communities as well. Okay, I'm going to stop sharing for a moment just so I could see all of you. And again, I'd love to see faces. So that's a little bit of just a little background on what I wanted to address in terms of what I read for your homework 1. Okay. Now I'm going to move on to today's lesson. Okay. So I'm going to share my screen again. I'm going to go back to the Canvas page, but I'm going to go back to modules. So last week we started talking about different engineering fields. And at the end, when you were making lists, I was talking to you about each one of the fields. So that was your first introduction to some engineering. And today we're going to be talking more about engineering fields. The first hour, I'm going to be with you. And then the second hour, Priti is going to be with you. And during Prithi's talk, she's going to be having you introduce you to different what we're calling obscure fields of engineering. And you're going to choose which one you want to investigate. And then you're going to show the class. So during the second 2 hours of the course, you're going to be working on looking at engineering fields and introduce each other to different fields. This first hour, I'm going to talk a little bit about where you can get resources to learn more about fields of engineering. And then I'm also going to talk about different industries engineers work in and also functions of an engineer, which is job descriptions. So I know I mentioned this last week, but we're talking about in this class, we're talking about the different engineering fields there are that you could get a degree in. We're talking about the different industries that you could work in. And we're talking about the different functions of an engineer. Functions of an engineer are the job descriptions, the roles that you have. Okay, so those 3 things are things you're going to be thinking about as you go through the course. The first module up here that you can see that's above week 0, if you click on that, you'll see that there's a link to the engineering department website. There's a link to all the videos they have in the Cabrillo library that are engineering videos. There's links, and many of them you could access remotely. There's a link to all the periodicals, which are magazines, engineering magazines that we have at Cabrillo, and almost all of them could be accessed remotely. And then we have a tabulated list of web resources that students have chosen from Engineering 5 in the past that they really loved. And then we have a PowerPoint slide on engineering disciplines. So I'm hoping that you're going to be looking at these in the next week, before next week, so you could start to explore engineering careers on your own. Okay, and now I'm going down to class 2, which is today. Close class 4, close class 3 and 4. I'm going to open up class 2. Okay. So the first thing I'm going to open up is, it says, welcome to class 2. And I opened it up in a new screen. Since I can't see you all now, I'm hoping that everybody's with me. Okay. There are 2 things that I'm going to have you do during your break. One is, I have a survey that half of you have already filled out, and it just gives the instructors information about you. Okay. So sometimes you have email addresses on Cabrillo. The email address that you have at Cabrillo isn't necessarily the email address you want us to contact with you with. So we have things like that. We like to know what interests you have in engineering. So we want you to fill out that. And then there's this really cool video that talks to you a lot about different products that engineers make. Okay. So I want you to watch these, or fill this out and watch this during the break. They're very short. Now I'm going back to the Canvas course. Okay, so as I said, under class notes, I have the first hour, and then Prithvi will have the next 2 hours. So what I want to do now is show you some PowerPoint slides. And some of these you've seen already, those of you that attended the engineering orientation. So I'm going to open this up anyway, and you'll get to see it for a second time. And I have to move my pictures. And let me open this up. Okay, could everybody see the first slide? Could somebody have their video on? So at least I could see somebody with a thumbs up. Okay. So last week I talked about a way that you could figure out which field of engineering you want to go into is working backwards. Think about the products that you want to design, and then Prithvi and Carl and I could help you work backwards on which field of engineering would be most likely an engineering field that would design things. So some of you may be really interested in structures. So again, these are products that engineers design. Some of you might be more interested in vehicles. And I noticed a number of you work in auto body or work on your car in our class. Some of you want to work on working on products that are in sustainable engineering, or sustainable engineering and sustainable energy, I should have said, sustainable energy. Some of you want to work on community systems, right? This is water treatment plant. These are roads. This is waste removal. This is planning of how communities are designed. Some of you are interested in working in agriculture. A lot of agriculture has to do with sustainability. How can we use only the amount of water that we need? How can we design agricultural systems where we don't have to use pesticides? How can we do indoor gardening, urban gardening? Some of you might be interested in designing medical devices. So everything in a doctor's office is designed by engineers. Some of you might be interested in being in the toy industry. Some of you might be interested in designing recreational products. Some of you might be interested in pharmaceuticals or beauty products, electronics. Kind of fun looking at an old-time TV, huh? Some of you might be interested in software and developing apps. Okay, so I'm going to stop sharing this for a moment. I'm going to actually, I'll just stay sharing. So I'm going to go back to the module. So what I just showed you was product in this, what engineering designs PowerPoint. That's what the PP stands for. So this was all engineering products. Okay. The next thing I want to show you, I'm going to open up in a new window. And this is a PDF. And let me again make it larger. What I did is I listed some of the main branches of engineering that we had talked about last week. And this is published by the Bureau of Labor Statistics. Bureau of Labor Statistics. It's a federal bureau that lists information about what different engineers do. And actually they list all jobs, and they also list what the salaries are on the job outlook. And towards the end of the semester, I'm going to have another class with you where we're going to look at job outlook. But at least now you could do a little bit more investigation on the details of some of the most popular fields of engineering. Yeah, I'm going to close this and I'm going to go back. So the first PowerPoint was on products. Maybe I should actually, let's rename it. I think that's a clearer title for it. And then this is engineering disciplines from the Bureau of Labor Statistics. And then I showed you this last week. I typed it while we were together, but now I typed it in a nicer table. And what someone had asked me, actually it was Louis C. You had asked me about categorizing, putting engineering disciplines in a category. And that's what I did here. Notice we have the main civil engineering category, the main mechanical engineering category, electrical engineering, chemical engineering, and industrial. And then notice what I did is I color coded them. So environmental engineering is the light orange, and it is underneath, it's a subcategory, a specialty of both civil and chemical engineering. Biological engineering, that was a field we didn't mention last week. And biological is not genetic engineering, and it's not biomedical engineering. Biological is environmental, bless you, is a more of a, yeah, you will, no problem. Biological is more of an environmental field of engineering, and it involves agriculture as well. And Davis, UC Davis has a great program in biological engineering. And notice, just as environmental, it's under civil and chemical. Agricultural is under 3 fields: civil, chemical, and mechanical, because a lot of agricultural engineers design robotics or design machines that are used in the agricultural industry. Robotics is under mechanical and electrical. Manufacturing is under mechanical and industrial, because it has to do with manufacturing lines and factories, which industrial engineers are a part of. And then nuclear engineering, I put under both electrical and chemical. So again, the idea of this class is to expose you to as much of engineering as we can. And so I'm giving you some resources that you could look at another time. Now I want to move to industries. And I'm going to open this again in another. I'm closing some of my windows. Okay. Services currently unavailable. What's that mean? Let's open it up in Word. I'm going to stop sharing for a moment, because when I want to share a different type of file, I have to open it up separately. Okay. Does everybody see this? Somebody give me a thumbs up. It says industries. Somebody give me a thumbs up. Priti, could you see it? Yeah. Okay. So it says every business is classified into different industries based on the products they make and the markets they cater to. These industries are classified on their specialties, which are based on the goods and the services they provide. While there are companies which belong to only one industry and provide industry-specific goods or services, there are also conglomerates, which are larger industries that cater to multiple industries. Sorry, conglomerates, which are big companies that cater to multiple industries. In fact, I visited India in 2010 and visited engineering companies, and there were some huge companies there that crossed in doing civil engineering. Like they made cars, they made structures, they made trains, they made airplanes. I can't remember the name of the company right now. Maybe Prithvi might know, but I'm sure I'll think of it at some point. So let's take a look at some industries. So aerospace is an industry. So, hey, I'm going to start calling your names out. And if you don't want to answer me, you could pass. But I would really like, our class to be more interactive than just me talking. So I'm going to say, let me go through the list. So Sam, what type
Yep.
of engineer would be hired in the aerospace industry? Think of the name, aerospace industry.
Like someone who works in like space, that kind of.
Yes, or remember the degrees we talked about last week, right? The different fields of engineering, an aerospace engineer.
Okay,
right?
yeah.
An aerospace engineer, an aeronautical engineer. In fact, the aerospace industry also employs mechanical engineers and electrical engineers and software engineers. So one industry may apply many different types of engineers. Thanks, Sam. I'm sorry, it sounded like maybe it was a technical or a tricky question, but actually it was a question that I was trying to make easy. Okay, another industry, transportation. So you could see planes in here, all the transportation systems. We use planes for transporting products. We use these cargo ships, right? So how about Luis C? Can you think of a field of engineering, a type of engineer that the transportation industry would hire?
I think maybe they would hire industrial engineers and maybe mechanical engineers.
Yep, definitely industrial engineers, because industrial engineers design huge systems, and you have to think that this is a huge system, because all those like Crocs that you're getting from China, the off-brand Crocs that you're getting from China, have to be bagged, packaged, put in these containers, shipped, etc. Okay, certainly mechanical, certainly programmers. Okay, thanks, Luis.
What about highway construction? Is that something
again?
different? What about like highway construction? Is that
Really
different?
great idea, Crystal. Yes, that would also be in transportation. I have a feeling I'd have to read through the words. Let's see. The main modes of transportation are air, land. Yeah, so they're including road and rail. Yes, so that would be civil engineering, it would be structural engineering. Great, thanks, Crystal. So we're just naming a few for each, but definitely yes. Okay, how about Alejandro? Let me see, make sure there's not more than one. No, Alejandro. Okay, computer industry. And now some of you might not have the audio, so you might have to write in the chat, and somebody might have to look at it for me. But Alejandro, computer industry. What types of engineers are hired in the computer industry?
Maybe a computer engineer.
Great, computer
then,
engineer. And remember, computer engineers are involved with the hardware. So what you're seeing right now in this person's hand, that's all the hardware. Hardware is stuff you could touch. What else, Alejandro?
Maybe electrical.
Electrical engineers, because there's all this circuitry in there. Yeah, how about another one? Not hardware, but
Software.
software engineers as well. And software engineering is like computer science. So somebody who has a computer science degree as well. Okay, thank you. Okay, we're up to Julio. How about telecommunication? And again, I can't see all your faces or the boxes, so I don't know if he has voice or not. Could somebody see the chat? He's requesting-
He asked to pass, Joanne, and
Oh, okay.
I can monitor the chat for
Okay,
us.
great, thanks. Julio,
Yeah.
no problem on passing, no problem at all. Ruben, want to try telecommunications? What type of engineers you think are involved in this?
Perhaps electrical.
Yeah, definitely electrical engineers. What else?
Mechanic.
Telecommunications would be these cell towers.
Yeah.
It would mean our regular phones in our house, our cell phones, right? Any kind of wireless or fiber optics. Can you think of another one besides electrical, Ruben?
Probably computer engineer.
Computer engineers, software engineers, even structural engineers. Structural engineers or civil engineers are the ones who are designing these towers. Okay, great. Thanks, Ruben. Okay, Cameron, you're next. Oh, I kind of gave this one away already, huh? I talked about ag already. Cameron, you want to give some names of engineers that would be involved in agricultural?
He's going to pass.
Okay, Cameron, no problem. Okay, how about Oscar? Agricultural engineers. I hear something, Oscar, but I don't hear your voice. Okay, I'm gonna pass for you. Okay, how about Adam? Adam, agricultural engineers. What kind of agricultural industry. What type of engineers?
Well, aside from ag engineers, there's probably
Yeah.
also chemical engineers.
Chemical engineers, great. What else?
They would also need, I think it's called logistics engineers to kind of manage all the product going in and out. 'Cause it's still a business.
Okay, so that would be industrial. So logistical engineer is more of a job title. It's not a field of engineering. So what you're talking about is the whole process. That would be more industrial engineering, certainly.
Got it.
Yeah, great. Thanks, Adam. Okay, Zane, you're up next. How about the construction industry?
Maybe an industrial engineer or civil engineer.
Industrial engineers, certainly, but more, usually the whole planning of building a structure is not done by an industrial engineer. The building of a structure is more done by, take another try, Zane.
Is it civil?
Yeah, civil engineers, construction engineers. So that is interesting because we talked about industrial engineers really being the ones that are running the show on organizing everything. But typically on any kind of construction project, it's all organized by civil and construction engineers and structural engineers. Zane, could you think of another type of engineer that would work inside that would be involved in the building that's not civil?
Electrical? Or
Yeah,
routing all the wires?
electrical engineers are going to be involved in doing all the circuitry and the lighting. And Zane, you were going to say something else.
Oh no, yeah, I was gonna say for all the wires and all that.
Right.
everything
Okay,
inside.
great. And then also mechanical engineers, because all the heating, the ventilation, the air conditioning is all done by mechanical engineers.
What
Thanks.
about geotechnical engineers?
Oh,
Is that
yeah,
a job
exactly.
title or is that
Great.
like a field
Crystal.
study?
Awesome, Crystal. Thank you so much for cutting in and adding more. Yes, geotechnical engineers definitely, because they would be involved in the design of the foundation of the building, right? And environmental engineers on how is the environment going to be affected by this big structure, including parking and such coming into the structure. Thank you.
An architectural engineer?
And architectural engineer. Okay, so you could see that I'm not telling you every single field of engineering that is involved in each one of these, but as you read through this, you're going to realize, and as you get more comfortable with the different fields of engineering. Okay, Ken's, you're next. Well, education. Educational institutions. Well, I'll tell you which type of engineer should be running the whole show at Cabrillo College. What is that?
Professors of engineering. Right?
Ken's, that's great. Like, of course, but no, that's not actually it. I'm not that egotistical. So engineering faculty should not be running the show at a college, but there is a type of engineer that I think would be well.
Wait, do you mean like who builds?
What?
Do you mean who builds
No, not
or
who builds it, but who runs the whole college. Who runs the whole factory? Who runs all of Safeway? Who runs all of a hospital? Ken? Industrial engineer.
got it?
They totally know how to organize things and process things. And I mean, I definitely think college presidents should be industrial engineers. I guess I am a little biased on that, but thank you, Kens. Okay, Jasmine, what about pharmaceutical engineers?
Biomedical.
Biomedical, well, biomedical is more the medical devices. So I would say, yes, if you're thinking about the medicine inside a syringe or something, that would be a biomedical device. But the pharmaceutical itself, the chemical itself would be the
Chemical
other area.
engineering.
Chemical engineering, and remember we talked about genetic engineering, right? So notice when they talk about pharmaceuticals, they're talking about these huge companies that not only make the manufacture the chemicals that are in the drug, but they're also the ones that are packaging it. So that's correct, Jasmine, that we need to have mechanical and biomedical engineers involved in the medical devices. See, it says medical devices here. Okay. Food engineer. I'm gonna just go on by myself because I need to pass it over to Priti in soon. So food engineers, agricultural engineers, people who do packaging, so chemical engineers. Healthcare industry, similar to the ones we already looked at. Hospitality industry. So this is about travel and tourism, Airbnb. Again, this is a big thing with industrial engineering, but Airbnb hires a ton of programmers. So software engineers who write the programs that allow you to book an Airbnb. The entertainment and sports industry. I'm going to just go through these kind of quickly. News.
Joanne, there's time, so it's okay.
Okay, news
Yeah.
and media. And okay, energy. Let's talk about energy then. Talking about renewable energy, industry, the non-renewable business industry, power, solar energy. So let's, Angel. Angel, what are some types of engineers that would be hired in the energy industry?
I have Angel not here, I think.
Okay. Okay, Kevin? Kevin?
For energy?
Yeah, for energy.
Probably electrical.
Electrical engineers, definitely. What else? See, it
Civil.
even says, it's even saying petroleum, right? They're talking about non-renewable energy sources too. So we learn that there's such thing as petroleum engineering, right? Almost every industry needs programmers. Almost every industry needs industrial engineers. Almost every industry needs electrical engineers and mechanical engineers, right? You're finding that really everything we touch has to do with engineering. Manufacturing, we talked about already. The music industry, there's a lot of electronics in here, acoustical engineering. Mining, we talked about mining engineering, geological engineering, geotechnical engineering. World Wide Web, that has to do with industrial again and programming. So I'm going to stop sharing this. So hopefully you're not only getting comfortable with the different fields of engineering, but you're also now getting more comfortable with the different types of industries that hire engineers. Okay, thumbs up. So these are things, the resources that we're putting on the Canvas page that you should be looking at. And at some point, what I'm going to do is, I'll decide what I'm gonna do and I'll tell you when I do it. Okay, I'm gonna go back and share the screen. And I'm going back to our module. I'm going back to our second class 2 module. So we looked at products, we looked at more about the disciplines, we looked at engineering categories, we looked at industries. And now what I want you to do is I'm going to show a video. It's a little old. It's actually more than a little old, but it's one of the few, actually, it's the only video that I found so far that talks about all the different functions of an engineer, job titles. And it's a little bit hokey. It's kind of designed for younger kids. But again, what I want you to concentrate on is one, this film is only on the bicycle industry. So one of the industries we mentioned was recreation and sports industry. Well, inside recreational and sports, if you look at a specialty, there's a bicycle industry. And a bicycle industry, oh, actually, who's next? Jose N. Jose N. What main field of engineers does the bicycle industry hire?
I don't think he's here.
Okay, Reed, what is the main field of engineering that hires, that the bicycle industry would hire? Reed? I know Reed was here before. Aiden?
I would think probably mechanical and material.
That's right. Correct. So the main field of engineering that the bicycle industry hires is mechanical engineers. So all the people you're going to see in this video, almost all of them they have degrees in mechanical engineering, but you'll notice when you see them at the end, they're going to have different job titles. So look at their job titles to understand what they actually do, even though they're all mechanical engineers and they all work in the they all work in the bike industry. They all have different job functions. So I'm going to open this up and hopefully it'll work on the first time.
And Reed typed mechanical into the chat.
Oh, okay, great. Thanks, Reed. Hang on a second. Okay, I want to get this bigger, so I have to move my screen. You might have to listen closely for the volume.
I don't have any volume.
No? Okay, hold on.
Yeah.
Hang on a second.
It's very faint.
Okay, hang on a sec.
Maybe can we play it in YouTube?
I'd have to find it in YouTube.
Let me see if I
have
can.
the link there.
Let me see what I can do. Hold on.
All right. Yeah, it's at the max volume.
Where's the video in the module?
It's under bike video. It's in module 2, class 2.
Okay, thanks. I'm in the wrong module. Okay.
Ken's, were you able to hear it? I see your face. Barely.
Can you hear it now?
No.
I can't hear it.
Yeah, okay.
Okay, I'm going to play it anyway, even though it's light, low. And then
Or
you can
what-
watch it outside.
Or we could have everybody watch it themselves right now. I don't know, unless you want to pause it and talk.
Great idea. Yeah, okay, why don't you guys all watch it yourself? It's only 8 minutes long. So I'm going to stop sharing. Thanks, Prithia. It's a great idea.
Well, I'm just still trying to see if I can get it louder. Um,
Are you guys watching it? Okay. Thank you.
Joanne, I did find it on YouTube too.
Okay, great. So I could,
Do you want me to share that link with you right now?
yes.
I'll put it in the chat, and
Put it
that
in the
way
chat.
everyone will have it. Yeah.
Okay, great. And then I could change it for the next class.
Joanne, I'm not able to create breakout rooms.
Okay, so oh, maybe I'll make you the co-host.
That would be great. Thank you.
Okay, now see if you can.
Okay.
Thanks, Priti.
Yes, I can. Thank you.
Everyone, let me know after you're finished. Just give me a thumbs up or something. Again, give me a thumbs up or a hand when you finished, so I know.
Hi, Angel. We're all watching a video independently that's been posted to the module. I think we're almost done, so you may want to watch it after the class.
Yeah, Angel, just hang on and during the break, and I'll talk to you about what you missed. Okay, a few have finished already. Aiden, keep the finger up, the thumb up. Thanks. Okay, about 7 of you have finished. Like about 10 now. Thanks, Adam. I like the kids when the kids are going like this. Okay, more than half of you have finished, so I'd like to continue. Okay. Crystal and Cody, I see your faces. Are you finished? Nod or something. Yeah. Okay.
Yeah,
Okay,
good.
so I'm going back. What, Crystal?
Oh, there's a feature where I can like have a digital thumb. It doesn't stay up though, I noticed.
Okay.
But I was doing that instead.
Okay, I'm going to go back to sharing the screen now. Okay, so I'm back in, again, I'm back to our class 2 module. Here's our class 2 module. And so that you just watch the bike video, and I'm going to replace the link in here to the YouTube link that Priti just gave me, but I'll do it when I leave class. So what you saw at the end of the video are the engineers with job titles, right? So let's take a look at what some of the job titles are. I'm going to open this in another window. And realize that these job titles exist no matter what field of engineering you're in and what industry you work in. So you could be a civil engineer who's doing research. You could be a mechanical engineer that's doing research. You could be an optical engineer doing research, or you could do development or design, or you could be a test engineer. Did you notice that there was one or two people at the end who were called test engineers? They were testing the bicycle parts. You know, some of them were testing them by riding them, and some of them were testing them by hooking the bike up to a machine that would simulate riding, right? Marketing and sales. Many engineers go into marketing and sales because they are really social and they have the technical skills to sell technical products. Field engineer, that's when you're actually working out in the field. And the word field means where your product is being used. So for a civil engineer, the field means you're outside on a construction site. But a mechanical engineer that designs manufacturing equipment, the field is really where the production is happening in a manufacturing facility. You could go into management. You notice that some of the titles were project engineer, right? Project engineer. Manufacturing engineer, that would be someone who has a degree, again, maybe in mechanical or maybe in manufacturing, but they're in charge of the manufacturing line. Okay, so I'm going to close this now. And I'm going to go back. So here was the list. I'll change this edit to function list, engineering functions list. You know, that was just the list I just showed you. But now I also have a PowerPoint. It's coming. That has each of the functions of an engineer and then the description of what it is. Development engineer, design engineer, test engineer, business and marketing, field engineer, management, etc. Okay, so I'm going back to the second module. So just to review what we looked at. One is we looked at a PowerPoint. Oh, how come it didn't get changed? Remember I changed it to, I changed it to products. Maybe I didn't save it. Oh, maybe it was still open on the other screen. Hang on, let's see. All right, so we looked at a PowerPoint of products. We looked at some information from the Bureau of Labor Statistics on different engineering fields. We looked at a table of the different categories of engineering grouped together. We looked at a PowerPoint on industries that hire engineers. We watched the bicycle video. We looked at a list of functions and then a PowerPoint of functions. So these are all things you could go back to and look at. In addition, during the break, remember, I'm going to open this up. During the break, I want you, if you haven't already completed the survey, to complete the survey and watch this cool video. This cool video shows you a lot more about what engineers do. So now I'm going to stop sharing and I'm going to look at all of you. Okay, I have just a few minutes. So any questions? What are some questions you have for me before you take your break and move on to working with Priti on the obscure fields of engineering?
I
Questions?
just have one question. It's
Yeah,
not
Cody.
entirely related to what we just watched, but I did want to ask you while we're here today. I haven't been able to find, but I think I came across earlier something that we need some sort of molding clay and coins, or is that
Yes.
just okay? What is that, and where do I find that?
Okay, Priti will talk to you about that. That's in preparation for, that was an announcement that she posted in preparation for next week's class. So she'll talk
Okay,
to you
for
about
next
that
week.
today.
Okay, good.
Okay.
And I can find that under announcements.
Yeah, but
Yes.
she'll talk to you about it.
Okay, thank you and sorry. Sorry.
Yeah, no problem at all. I'm hoping, I think I like the idea that you have more than one teacher because you're learning from different people. You're getting different viewpoints and we all have different fields of engineering. But sometimes we're trying to make it clear that who does what. Okay, questions for you guys? Okay, give me a thumbs up. Please come and see me during office hours. Some of you have and some of you have not. Remember, it's every day but Thursdays, because I'm teaching, 1 to 2. And if that time does not work for you, then just message me and we can set up another time, okay? And a reminder that on week 4 of this class, when I go over engineering education, I'm going to set up appointments for all of you to meet with me for 30 minutes. So you are going to be meeting with me anyway, but you could come and hang out anyway in the meantime before then. Okay, thanks a lot. Have a great week. I'm going to sign off. So you're co-host, Priti, so everything should be fine, right?
I hope so.
Okay,
Yes.
I'm going to leave the meeting and let.
and she's gone like instantaneously. Okay, she promised you all a break, and I want to honor that. So we're going to take a break. What time is it? 12:07. Okay, let's come back at 12:25. And I think this might be a good time to just answer your question, Cody, about the next class. So this might just be a good time for some announcements about the next class. So the next class, the module will open tonight, and it opens at 9 o'clock. I'm not sure if we mentioned this before, but we teach this class, Engineering 5, twice on Thursdays. We have your section from 11:10 to 2:10, and we have an evening section from 6 to 9 p.m. So the way we've set it up is that every week, the following week's module will open at 9 p.m. after that section is complete. So I am trying to get over to our module in this class here. Give me a second. Okay, engineering. Okay, just to talk about next week. So Cody, can you repeat your question for me?
Yeah, I had come across the assignment and I couldn't figure out where to find it again. So, but I had saw that we had required some sort of clay and coins, and that's what I wasn't sure if it was for this week or next week, and I was glad to.
Okay, great. Yeah, so it's for next week. And so the other thing is that in the classes with me, the general layout of the class will be like the first hour or so, I talk about one of the topics of the day or many of the topics, just like Joanne talked about this first hour about many topics. And then the latter half of the class will be doing an activity together in breakout rooms. So next week, our activity is going to involve clay, pennies, and some water. And so last Friday or last Sunday, I think we sent out the announcement to let you know to get some clay. And the thing about it is Play-Doh will not work. So I know all of us have Play-Doh lying around, but it doesn't work for this activity. So I wanted to give you enough time to get a little bit of clay, and you only need 4 ounces of clay. And let me just see if this little container has a volume on it. It does not, but 4 ounces of clay probably looks about double this amount here. Let me see if I can actually get it out. And the other thing I wanted to say was that with the clay is that you, if there's somebody who's got some and willing to share, if you live near each other and you want to let us know, we could somehow hook you up, or if you want to put it in the chat right now. So this is probably about 2 ounces of clay, and it came out of this little Play-Doh, and it came out of this little Play-Doh container. So you need about double this, although if this is all you have, no big deal. Whatever you have, we will work with, but it does need to be non-soluble. And then I asked you to have some coins. And the reason I said coins, this is a bag of pennies. I don't know, it's hard to see. Yeah, there we go. Is because we know the weight of coins, and we can say, oh, if I have 20 pennies, I know it weighs about this many grams. However, if you don't have pennies, quarters, nickels, whatever lying around, you know, washers, nails, just be creative. You might even have little weights lying around. You don't want something too heavy. You want something where you can gradually add a weight. So you don't want to just add an orange on, but if you want to get a whole bunch of grapes and add a grape at a time, that would work too. Okay, so lots of different options, especially if you have a kitchen scale and you could get the weight of what you wind up using afterwards, that's even better. Any questions on that?
Yeah, approximately how many coins are we going to need?
Well, if you use quarters, you might need less than pennies, but I say about 100 pennies.
Whoa, okay, so dependent on mass, I see.
Yeah, it's dependent on mass. And I don't want to give away the activity because you know what? A lot of you will just do it ahead of time, and then your results won't match the people who haven't done it ahead of time, and then it's just not fair, you know, so. And some of you may already know, one person actually is in another class of mine, and a former student sort of blurted it out, and I don't know if they caught it or not, but in any case, let's try to get these things together. And if at the end of the day you absolutely cannot get clay, then you know you'll be in a breakout room, and I will ask you to contribute to the people in the breakout room doing the project. And then you'll have to write up your assessment of the project based on what you see happening in the breakout room. So it's going to be much better or easier to write it up later if you do it. But if you don't do it, then you'll have to rely on other people's experiences to submit your follow-up assignment. Okay. Any other questions on anything? All right. So, oh, and someone has put, you can find small amounts of clay at Lens Arts. Is that in Santa Cruz? Could, Ulysses, do you know where Lens Arts is?
It's near downtown.
It's near downtown.
Like
Okay.
Off River Street, if I recall.
Kind of in that area.
Okay. I guess you can Google Lens Arts if you want. And I don't want you to spend a terrible amount of money either. So the cheapest non-soluble clay you can find. And if you know someone who took Engineering 5 last semester, they might have it. So maybe you could grab it from them and borrow it. All right, the next part of this class is, like I said, an opportunity for you to explore. Oh, what happened here? I renamed all these breakout rooms and then they got renamed to nothing. How bizarre. Okay, it's an opportunity for you to explore what we call obscure fields of engineering. And what I am going to do is, as I am creating these breakout rooms again, I am going to put these fields of engineering inside of our, well, I was trying to, but it didn't really, no, that didn't really work. Okay, so let me just name them as I create the breakout rooms. So what I want you to do is think about which field you want to explore. We're going to go into breakout rooms of no more than 3 people per breakout room, and you will be given a prompt, which is to use the resources Joanne showed you earlier to investigate this field of engineering more. You'll put together like maybe a set of 5 PowerPoint slides, or not, you know, Google Slides, however you want to do it, or some sort of a presentation. And if slides, you know, aren't in your group's thing, then you'll just talk. But you're going to give back to us some information about it so that we know more about what that field is and what you can expect to earn, what kind of degrees you need to get, what kind of work you can expect to do on these particular types of fields. So the ones we're going to look at are petroleum. So think about it while I'm saying them. Think about what interests you out of the ones I'm saying. Petroleum, acoustical, ceramic, food, marine, sorry, I'm also typing as I'm speaking, so it's harder. Mechatronics, metallurgical, micro, or I'm going to say nanotechnology, ocean, and let's see, oh, optical, and I said, okay, so I said, remind me, did I say food? Yes, okay. Biomedical. So I said acoustical, petroleum, food, marine,
Ceramic.
mechatronics, ceramic. Thank you. I did not type that one in. Okay. Metallurgical, optical, ocean, biomedical.
Nanotech.
Okay, great. Ceramics and nanotech. So I'm missing one.
Optical and biomedical. You listed everything I've got here. Petroleum, acoustical, ceramic, food, marine, megatronics, metallurgical, nanotech, ocean, optical, biomed.
All right, so we'll add one more. It's between agriculture. Oh, robotics. That was the other one that I was thinking. Okay, so we'll do robotics. Okay. Robotics is, it may not seem obscure, but it's actually an emerging field right now. So what I need you to do is type into the chat, not yet, do not do that yet, but in a minute, the one you prefer. And I will try to give everybody their first choice, but that may not be possible. And I have to assign you to the breakout room, and I don't want more than 3 people in a breakout room. So I would open the breakout rooms and let you all just pick a breakout room and go in there, but then we might find too many people in a breakout room, which then, you know, I don't know what to do about that. So let me read them again. Decide what you want and type it into the chat, and then I'll tell you when to hit return. So the options are petroleum, acoustical, food, marine, mechatronics, metallurgical, optical, ocean, biomedical, ceramics, robotics, and nanotechnology. And let me also put in the prompt into the chat before we even open the breakout rooms. So in your group, you're going to have 30 minutes to prepare a 5-minute presentation on one of these fields of engineering. And what I would like you to find is the type of products and systems designed by that type of engineer, the industry that employs that type of engineer, the environment the type of engineer works in, the specialties of that, like sub-branches of that type of engineering, and the major engineering field that this falls under. So some may not have subspecialties, in which case you need to say they don't have subspecialties. But most of these probably fall under a major field of engineering, and if not, then you need to say it's its own field of engineering. And the average salary. I'd also like you to, you know, tell us what this field of engineering encompasses. What is this, you know, what does it mean to be an acoustical engineer? Tell us that first. If you do slides on your first set of slides, perhaps you could put, you know, the field of engineering you explored and the names of the people in your group, something like that, something of an intro so we all get to know you. Pick someone to speak for your group. Okay, So now tell me what you want. Everyone hit return. All right. So what I'm going to do is just start assigning people. And when I get to 3 in a group, then I will have to say, if you pick that, then you need to pick something else. Does that sound okay to everybody? And it's all just in fun. You know, either way you learn about something. So I have food, Kevin. Ceramic is Cody. Ulysses is acoustical. Okay. Robotics. So this is going to take a minute. Metallurgical. This is great. You guys all have different ones that you want, which is really great. Aiden. Acoustical Lewis. Marine. Okay, so food is full, and it has Sam, Alex, and Kevin. So if you have food later on, then I need you to pick something else. Acoustical is also full. I have Jasmine, Luis C, and Ulysses in acoustical. So please pick something else if you had picked that. So Carlos, I'll need you to pick something else. Brandon, what's that? Okay, robotics. Okay, robotics is now full. And in robotics, I have Alejandro, Luis Q, and Nathan. Thomas, would you be okay with marine instead of ocean? You're the only one that put ocean. Okay, great. All right. Let's see, where was I? Mechatronics. Great. We've got a really great distribution, so thank you, everyone. And I may have a group of 4. Jason, robotics is full. Julio, robotics is full. So could you 2 pick something else? Okay. What options are left? All right. We've got 1 spot in metallurgical, 2 spots in ceramics, and 1 spot in nanotech. Okay, so Jason, you've got nanotech. Reed, you want marine, and Angel, you want marine. I can put, those are taken. Will you do ocean? Actually, Reed and Angel. And Crystal, I know you put ocean too, but I put you in marine. So you're in marine. Would you like ocean or marine, Crystal? Reed will do ocean, thank you. Okay, and what about Angel? I guess Angel, you don't have a choice. I'm putting you there. It's similar, but it's not. Okay, so, and Crystal would prefer ocean. So you're gonna have to put her there, which means Angel, you get marine. Okay, well, we've figured that one out now. Okay, all right, I have 2 people not assigned, Julio and Oscar. So I need you guys to pick something. Julio and Oscar. Julio, thank you. You got ceramics. It's yours. And I'm going to go ahead and open the rooms, and you can all go in. You'll have 30 minutes to answer the prompt and come back. You can always come back and ask me questions. And you can, if you need more time, let me know. So Oscar, you have options of ocean, ceramics. Where I put it in the chat, Cody. I put the prompt in the chat. Oh, where do you find information? Good question. Okay. Discussion post. I'm going to publish the discussion post, and it has all the information there.
Thank you.
You're welcome. Thanks for asking that. Okay, and I have to broadcast that message. Okay. Oscar, ceramics, you got it. Ceramics. All right. Hopefully you all had enough time, and now we'd like to hear what you found, and in this way you're sharing your knowledge on these fields that we know less about, that aren't as mainstream. And I think Ken's group volunteered to go first. They are the marine engineers. So did we do this before, where everybody turns off their screen, their video, except Ken's group? And that's Ken's, Angel, and Thomas. And that way they're the focus of what we see. So let's all do that. Oh, and then when you turn off your video, the other thing you need to do is hover over somebody who has their video off and say hide non-video participants. And that leaves behind just Ken's, Angel, and Thomas. So
Angel and Thomas both don't have cameras, so I'm going solo. It's okay though.
that's fine.
If we did a presentation, do I share my screen or can I?
Yeah, go ahead, share your screen. And then in your view, you should see Ken's and I next to the shared screen. And that's perfect. All right.
Okay. Oops. Wait, it's on the end. Okay, we had marine engineering, and my group was Angel, me, and Thomas. So marine engineering falls under mechanical engineering, and some of the specialties that marine engineers may have are.
And Ken's, I'm having a hard time hearing you. Do you have a volume you could share up, turn up a little?
Let me make sure the mic's on the right one.
Now I can hear you better.
You can hear me better? Okay.
Go ahead.
Let me go back to present. Okay, so it falls under mechanical engineering, and some of the specialties that a marine engineer might have are automation and control, refrigeration, air conditioning, instrumentation, pneumatics and hydraulics, naval architecture, and naval science. So they design, develop, produce, and maintain equipment that's used at sea as well as on board the vessels. And examples of this are propulsion, mechanics, communication, water distribution,
So your volume went out again.
Huh?
Your volume got very low again.
Oh, maybe my mic gets moved when I talk. I don't know.
Yeah, now we can hear you again. Perfect.
Okay, sorry. And then on average, they have a salary of about 80,000 per year. It can go up or lower. I think it kind of just depends on what company you're working for. And then examples of industries who employ marine engineers are cruise ships, shipping companies, naval vessels, basically anything that needs a ship would be employing a marine engineer. And then I read that it's physically and emotionally demanding because most of the people who do graduate as marine engineers work on board ships and their contracts can be 4 to 6 months. And in that time, you're only able to go on shore when you're in port, or even if you have time for that. And some engineers are able to get jobs onshore, but it's predominantly that you work offshore. Oh, and that's it.
Great. And what got you guys interested in marine engineering?
For me, it was something that honestly I hadn't really heard about. I knew obviously there were probably engineers on ships, but it wasn't something that I ever really thought about.
Cool. So next week, I mentioned this to the Ocean Engineering group. We're going to have Rob Weiland, who's actually a professor at Cabrillo, come and talk with us. And he's had a bit of experience in marine and ocean engineering. So we'll hear a lot more about his personal experience, which I think will further enhance what you guys just learned from Ken's group. So thank you. Great. All right, do we have a group that's willing to go next? And actually, if you're willing to go, would you mind just typing in the chat if you're willing to go next? Oh, Crystal, you're willing to go. All right.
Yeah, I did not ask my partner yet, but I can talk about it since it seems fitting since we just talked about marine engineering.
Perfect. You guys are perfect to follow up, and that's Crystal and Reed.
Yes. So we were very confused in the beginning about ocean engineering because it didn't show up like in the regular Bureau of Labor Statistics. But for what I gathered, it's broad. But one of the functions that they may do is working with oceanographers, and so they'll be on the engineering side of designing research equipment, like buoys. I think that's how you say it.
Buoys.
Yeah, maybe you might know more about what that's used for in research.
Sure, I can talk about that.
Yeah, because I saw that listed and I'm like, oh, I know that I don't know enough to talk on that research equipment, but that's a thing that they do. They also, or offshore drilling rigs, like is a thing that they can do, but it's like starting to decline. Like we're going to be moving a little bit less off of oil. And so some of the things that oceanographers or ocean engineers might do is focus in energy. So even dams, like it doesn't have to necessarily be totally all up in the ocean, but like on the shores as well, figuring out different ways to harness energy. I was wondering what the difference is between ocean engineering is and like marine and naval. And it sounds like the marine and naval are more towards like maintenance of ships and making those kind of vehicles. And with ocean, it's more has to do with the water itself.
Definitely, that's right. Yes. Did you guys find out how much ocean engineers might make?
I didn't find that. I don't know if my partner did. Like when we were going back into the breakout room, like, oh shoot, can you find out how much they make? So I don't know.
Reed, do you want to weigh in? And if you're speaking, we can't hear you because you're probably muted. I don't hear Reed.
Yeah.
Hello?
Oh, now we hear you. Okay.
Okay, cool. That's okay, cool. So yeah, they start out at an average of around like 98. They get around. That's the average, and like $47 an hour, but they can go all the way up to like 135, and some of them have even got up to 150, but mainly around that 100,000 to 135 range.
That sounds pretty big. I wonder if they count the people that do the oil stuff, because I know that people that work with oil like make a lot of money, and that might change the average. I don't know.
And
Because
this,
it seems really broad from what I found.
and in this class, nobody chose petroleum, so we can't follow up. But no, that seems very lucrative. Were you going to add something, Reed?
Yeah, that's what I thought too. But I don't know. When I was looking this up, everything was pretty wild and leaning towards more marine side. Everything I was finding.
So ocean engineering, like I mentioned, Rob is a ocean engineer, and it's not a degree. There's, I think, one place that offers it as a degree.
There's 10
Oh, there's 10.
in the US, yeah.
Okay, great. So a lot of people who get into it study electrical or mechanical. Did you guys figure out what the third one was?
No.
No. I'd have to look at my notes. So what happens is that you wind up going and studying one of these degrees, and then you find out that, oh, I might be able to work with this organization that does a lot of work in the ocean environment, such as an oil rig. Like you go and work for Chevron as an electrical engineer, and then you find yourself doing a lot of ocean engineering work. But the other thing that they mentioned is the research aspect of this. And ocean engineers do a lot of research, and that's what Rob is going to talk about, is his research. One of the things Crystal mentioned was the buoys. And buoys are these things that float on the ocean surface, and you guys have seen them in the harbor, the little balls, but the research buoys are actually stuff that collects data. So for example, for some reason, this past week, I've been talking a lot about tsunamis and earthquakes, and a buoy out in the ocean can sense the height of a wave. And so our tsunami warning systems, those down in Santa Cruz, are linked to buoys. So when a buoy raises a certain level or drops a certain level, then we can know that a tsunami is on its way. That's just one example. They can measure salinity of the air, sea surface temperature, all sorts of other information that's important to marine biologists and oceanographers and other scientists out there. So I'm not the expert on it, but Rob is, and we're very lucky he'll be coming and joining us to talk more about that. And I just wanted to look up that third field of engineering that he had mentioned. Oh, manufacturing engineering. So he said mechanical, electrical, and manufacturing engineering, I believe, were the three.
What I saw is they said one thing that they could do is like finding, they said unorthodox ways of transportation. I'm not sure what that means, but that might mean something that has something to do with manufacturing.
Interesting. Okay. All right. Thank you, guys. Did you have anything more you wanted to add? And ceramics is next.
No, but I'm glad we're going to have an expert talk about it because.
Okay. So be sure you upload something, though, that we can refer to, some sort of a document to that discussion board that you can share with everybody. Okay. All right. Ceramics is Cody, Julio, F, and Oscar.
Hi. Thank you, Preeti. We did our research and we came up with a few different things. So we're doing ceramics. We found that that was underneath the materials heading of engineering. The types of products that ceramics engineers make are fiber optics, electronic ceramics, china dishes, and electrical insulators, as well as ceramic tiles for spacecraft. Some of the types of industries that employ ceramic engineers are manufacturing plants, government agencies, and commercial support facilities. we found that the environment that ceramic engineers mostly work in is going to be a factory setting. And the specialties for ceramic engineers are glass, whiteware such as china dishes and electrical insulators, abrasives, cements, structural ceramics, superconductors, materials, as well as non-metallic nuclear fuels, I believe. And the salary mean average is about 126,000 in 2008, and you know, I think the starting range is between 50 and 100,000 a year.
Okay, great. And
Both the microphones of Julio and Oscar are temperamental, so I went ahead and jumped in there.
thank you. So great. You know, ceramics falls under materials engineering, like Cody just said. And Carl, I think Ewald is gonna, I think that's, no, maybe not. I think Joanne is actually gonna talk more about materials engineering later in the semester. But it's an exciting field because materials is where a lot of technological advances are taking place today. Like you mentioned, fiber optics, that's relatively new in the history of materials. But like things like carbon fiber, you know, composites, a lot of energy is going into coming up with great composites that can serve a variety of harsh environments. So what's going to keep us alive on Mars is the innovation of these materials. So it is a really exciting field. Ceramics happen to be able to withstand extreme heats, which is why they are on the space shuttle. As they re-enter the atmosphere, the shuttles don't burn up unless we lose a ceramic tile. They also tend to be brittle. So, you know, how can we harness the temperature characteristics of ceramics and put it with a more ductile material? That's where you come into the composites of materials, which is really an exciting field to be in right now. So thank you for that introduction, and you guys will hear more about it later this semester. Okay, my next volunteer group. All right, then I'll just call on someone. Acoustical, you're up. You look cold.
That's us. I'm gonna share.
Go ahead. Okay, sounds good.
So we're the acoustical engineering team, and acoustical is relating to sound in the sense of hearing and the science behind sound. So that manifests itself in engineering in different ways. And you guys feel free to jump in and talk about
some types and products and systems that they work in and design are like auditoriums, like performance spaces with really high quality acoustics with like reverb and whatnot, auditoriums. Or they also work with soundproofing recording studios as well, or even they work in the medical field with helping create hearing aids or hearing devices. They also work with sonar equipment for warcraft or fishing. They also work to lessen, alter, or muffle vibrations in machinery to help with noise pollution or vibrations that come from earthquakes that affect buildings, so they won't like topple over when an earthquake happens. And they also work with musical instruments or electronic devices that could reproduce sound.
Some industries employ acoustical engineers or constructional music and medical.
Ulysses, I'm having a
They'll
hard
have to
time
work for
hearing you.
different types of people depending on the projects they have. So if you want to create like, it could be my internet. It's kind of unstable right now.
Okay,
hear me?
yeah. We can
Hello?
hear you very faint. I don't know if you can get closer to your mic or something.
I'll try. Is this better?
Yes, much better.
Okay. Okay, so yeah, they tend to work with other types of engineers depending on the projects. So like if they want to create a recording studio or like an opera house, they'll have to work with construction like civil engineers or architects. And they'll also have to work with electrical engineers if they want to create like, I don't know, like speakers or headphones, stuff like that.
They will also work with materials engineers in, looking for ways to manipulate the way that sound waves reflect or absorb. And so the acoustical engineering, I guess, could fall under the civil architectural engineering, electrical engineering, and bioengineering. And the salaries range between 50 to 60K on average. The average being 80, but it can go as high as 140.
Yeah, the starting ranging between 50 and 60.
And the requirements to become an acoustical engineer are at least 4 years in electrical engineering to get a degree for it. But depending on what you want to do, you might have to do, or you might have to get a civil engineering degree or architectural engineering degree. But if you want to do things that are more advanced, like underwater acoustics, medical ultrasonics, or signal processing, you have to get a master's degree. And that's it.
Wow, thank you. It sounds like this is a really a field where you can be super creative.
Yeah, and it also you tend to work with a lot of people too.
Yeah. What got you guys interested in acoustical engineering?
Well, it's not like my main idea or type of career, but I was interested in creating like headphones or speakers, stuff like that.
Oh, great. Yeah.
For me, it was
yeah.
Musical instruments, and I recently picked up a piano, and I was really interested in the way that the sounds of the piano can be modified. So
Very cool. Yeah, that's fascinating.
I've always
Okay,
been like in love with sound and like auditoriums and how everything's super reverberated and whatnot in like bathrooms or hallways. It just, I don't know, that always amazed me.
It is really incredible how you can dampen a sound when you don't want it and when you can enhance a sound when you need to. And materials play a big role in that. So that's pretty exciting. Thank you.
Thank you.
All right. It looks like food is ready to go. So let's have food and then followed by robotics and then metallurgy.
Okay,
Hi, Sam.
Hello. I'm gonna try and share my screen real quick.
Sure. And food is Alex, Kevin, and Sam. Do you see a little green button at the bottom?
Yeah. Let's see. Yeah, when I press on that button, it brings up a screen. Wait.
Where you have to choose. Yeah, and your window has to be open for it to see it, to choose from. So it'll be food, robotics, metallurgy, and then nano. And after that, it'll be Mechatronics, which is the last one. All right, and are you ready, Sam, or should we come back?
Maybe come back. I'm having a hard time figuring it out. So
all right, maybe you want to chat
or-
amongst yourself and someone else you can go after robotics. Let's have robotics go instead, and while they figure this out. And robotics is, where are my robotics? Alejandro, Luis Q, and Nathan. Thank you. Yeah.
All right, here, let me share my screen real quick. We got a little presentation. Let's see. All right, can you see it good?
Yes, we can see it.
Cool. So our topic is robotics engineering. And what robotics engineering is all about is the design of robots for taking over human tasks that are deemed either dangerous or mundane. So I read a little bit about like them trying to make robots to help out with things like mining, and a really good example of just helping out a tedious task are the Roombas. And while I was looking into this, I found a cool website called Boston Dynamics. And there's this really cool robot called Atlas that I just want to show you guys real quick. Shoot, hang on. I'll just click the link.
I think it's your next tab.
Yeah, but I can't click it because there's this weird bar thing on the top.
Oh.
It's fine. That's fine. I got it. But these guys make a whole lot of really cool robots, and this is a cool little demonstration of Atlas. So there have been.
Should we all hold up a number score on how they did on the math performance there?
Yeah, do you think they could do well in the Olympics?
I know, exactly. They're getting some tens.
All right, and then when looking into the.
Where's our screaming Roomba at, Michael?
That was a mistake. I didn't mean to open that because there's profanity in there. It's just a fun video if you want to check it out. But yeah, when I was looking into
You'll post these slides so everyone can.
Okay, cool. But yeah, when I was looking into the environment, it seems that they go into a myriad of different places, such as offices, manufacturing plants, and laboratories as well, working on their machines. And they can generally be found also kind of working with other industries. And per week, there's generally around 40-hour work weeks, but they will quite frequently have to work overtime as well. Somebody else want to cover this one?
So for employment and salary, so robotic engineers, they're typically hired by industries such as defense and public safety, manufacturing, and mining. So typically for a robotics engineer, their wages average around 95K, but that can be lower or higher depending on like the state they're working in, the amount of experience they have, the education. And I also included a little list that shows the highest paying robotic salaries by city. So for example, the top 5 would be Pasadena, California, Pittsburgh, Stevensville, Boston, and Santa Barbara.
And for the meal/major, robotics falls under both mechanical and electrical industries. And what I found is that they work around like designing systems for the military, tool systems, construction for other companies with technical interests. And I also found that they work around ROVs, so ocean exploration. It could include many different topics for aerospace. It's a multitude of varieties for robots to have a multitude of possibilities. And some of the sub branches are computer science, character animation, machine design, cognitive science, and biomechanics.
All
And
right,
that's
yeah,
about it.
That's everything.
That's about it.
Very cool. And what got you interested in robotics? Picking this one.
I'll go first. So for robotics, for my interest was that I was actually part of the robotics club at Baltimore High School, and so I was always intrigued about how systems work, like cars and stuff, and so it's always intriguing to know about systems of how should we make this possible, and it's been an interest for me.
Cool.
So
Nathan, Alejandro, do you want to add?
Yeah, when I was back in junior high, I had this one physics teacher who was teaching us how to make little like ROV vehicles, and I thought that was really cool. And then at around my senior year in high school, I decided to, when I was applying to different colleges, I applied to UCSC under robotics, and I was initially going to go there. Then I realized I didn't know anything about it, and I decided it would be better to come here instead. So, I've had a pretty decent interest in it for a while.
Awesome. Thank you. So later in the semester, when we get to mechanical engineering, a former Cabrillo grad named Aaron will be joining us, and he's working in the robotics field right now. And he'll tell you a little bit about his path and how he got there, and his current application in robotics. And robotics is another one of those just getting out of control new fields, because there's a lot of things we can do with robots that save human lives, and so it's something we want to keep in mind. Like, as engineers, we want to always, the safety of lives and the environment is one of our top priorities. You'll hear more about that in ethics, but robots and robotics is one of those things that is really at the forefront of making some new things possible. And I think you touched on the biomedical application of it, but with the combination of nanotechnology, which you'll hear about later today, there's another exciting new application of robotics as well. Thank you, guys. Who did I say was next? Oh, we were going to go back to food, right? Yeah, food. Did you guys figure out, Sam, Kevin, and Alex, how to get your screen going?
Not sure, Sam, did you figure out how to do it? Because I could try sharing it for
Yeah, if you can try and figure it out. I'm still not for sure. I can try again though.
And Alex, you were breaking up a little bit. Okay.
Sam, I could try and do it if you still.
Kevin, can you try and do it?
Yeah.
All right. Perfect. We can see it. Oops. There we go.
Okay, so we decided to look into food engineering. So let's see. So food engineers create systems for processing, producing, and distributing. Engineers who go into this field will develop ways in which to learn and discover different ways to improve and maintain processing systems. They also find ways to store food for like longer times more efficiently.
The industry that employs that type of engineer would be companies like Nestle, Cargill Incorporation, Fiberstar, General Mills, and Hormel Foods. The environment that food engineers work in would be in a factory floor or inside.
All right, the environment a food engineer works in.
Alex, your voice is broken up. You're not coming through really clear. Yeah, it's the same. Can Sam or Kevin speak instead? Okay.
So the environment that food engineers work in. So from what he found, most food engineering jobs are done in some sort of factory or lab. This can be because of the packing of the food products or testing of whether the food is safe to eat or not. Many food engineers are employed by food industries to make sure their products are up to par with guidelines or to test whether or not they are okay to consume. This kind of work could be done in a lab or testing facility provided by the industry. So some of the major engineering fields food engineering falls under include electrical, mechanical, civil, chemical, industrial, and agricultural engineering.
All right, can you guys hear me now?
Yes, we can hear you. Thank you, Alex.
Sorry, I switched to my computer to see if I could share my screen, and I guess it wasn't having it. All right, the average salary of a food engineer. We found that the average salary of a food engineer was around $66,000 per year. A very experienced food engineer, the 90th percentile, makes around $105,000 per year. A lower experienced /level food engineer, 25th percentile, makes an average of $39,500 per year.
Tell us what this field of engineering encompasses. Food engineering is a scientific, academic, and professional field that interprets and applies principles of engineering, science, and mathematics to food, manufacturing, and operations, including the processing, production, handling, storage, conservation, control, packaging, and distribution of food products. And that's it.
Can anyone tell us what is an emerging area of a food engineer that's just come about in the last couple of years that's very mainstream now?
I'm not sure, but I know that like the packaging of food and that kind of stuff is really that's mainly what food engineering is about, is packaging and processing the food. But
Right, like preserving the food. How do we get food from point A to point B all the way around the world is a big part of what food engineers do. And another part of what food engineers are doing are things like, you've heard of Beyond Burger and
I'm about to say it.
yeah, what's the other one? I can't remember.
Impossible.
Impossible. What?
The Impossible Burger.
Yeah, the Impossible Burger. So, another really fascinating field. Look at all those degrees that they mentioned that you could be going into, and then you could be working in this environment to try and create foods to feed our exploding world population in a way that gets us off a meat-based diet, which is very hard to feed the population that we have today on a meat-based diet. Very fascinating. Very cool opportunities in that environment. I know Joanne is going to talk about agricultural engineering towards the end of the semester, but I don't know if she'll talk more about food. So if this is something that interests you, you should look more into it and come to that class with more questions so she can engage you a little bit more in that. As I'm listening to you all, I'm realizing it'd be really great to have your sources. So in your discussion post, I'm going to ask if you can list some of your sources. I'm going to be adding that onto the discussion board post. So just something to keep in mind before you close your windows is maybe capture, copy all of those websites that you might have gone to get all this information, so that anybody who's interested can look a little further into those websites as well. I think that'd be really great. All right, Metallurgy, you're up. Adam and Aiden.
Hello, everyone.
Hi.
Right, so we have Metallurgy. I think Aiden's going to pull up the
Yep.
presentation now, and we're going to be going back and forth between each slide, so we'll both be presenting at the same time.
You guys see that?
Yep, we can see it.
All right. So we're doing metallurgy, and some of the things we're talking about is what metallurgical engineers do, how much they make, the industries and environments they work in, the various specialities within metallurgical engineering, and how it ties in with other engineering fields.
Now, the first thing about what a metallurgical engineer actually does, I found this really good quote from ZipRecruiter that just says, a metallurgical engineer develops ways to extract metal materials and produce metal products more efficiently. And in a nutshell, they just develop the methods and tools for processing and working metal into something usable. So if you imagine any object around you that's made of metal, a metallurgical engineer was involved at some point in the process. And because of this, these type of engineers produce many products just from vehicles, buildings, materials for specialized use and specialized tools. And it's hard to encompass everything that they would go into because they're essentially the starting point where all this metal would be processed into something usable and then branch out going into other fields or other areas of engineering.
How much does a metallurgical engineer make? This is pretty variable because it's such a broad field and there's like so many different industries you can work in with it. But on average, you're going to make about $77,000 a year. You'll usually start off around $55,000 or $60,000 a year. And after a long time working in the field, like if you become a high level engineer, you can make over $120,000. And this also really depends if you go into like the refining aspect of metallurgical engineering. Like if you're working at a mine or refining plant, you won't make as much as someone who works at Boeing, for example, designing alloys for new planes. But that's the average you'll make.
Now, as far as the industries that a metallurgical engineer can work in, this also varies, but a metallurgical engineer can primarily be found in the mining industry as well as related fields such as refining and manufacturing. And again, however, metallurgical engineers can also apply their skills in a range of industries that require shaping the metal, working the metal, processing it. The automotive industry is very well known, aerospace as well, as mentioned before, and constructions of large buildings where they need large amounts of processed metal for very specific uses that need to fall under very specific criteria of strength, durability, toughness, and other types of benefits.
A metallurgical engineer can work in a variety of environments. For example, they could work in a lab where they prototype new methods of refining or making different alloys, or they could work in the manufacturing plants themselves, directing the production and distribution of different alloys and metals. It's really quite variable. You can also go into a more computer-aided design aspect of it, where you design pieces and parts using the computer and figure out how to apply that design into a real-world application.
Now, once we get to the specialties within metallurgical engineering, the metallurgical engineering is separated into two broad categories, extractive and physical. Extractive metallurgical engineering works in mining, refining, devising and applying methods to extract metals from ore and purifying it into usable metal. So if you've ever played Minecraft, this is essentially what you would be doing when you take your metal ores and make it into some type of material like an ingot. Physical metallurgical engineers study the physical and chemical structure of different metals and alloys, and they use this knowledge to create the ideal alloy for a given application. So a certain researcher at Boeing might need to create a specific alloy of metal that can withstand the and temperature differences for a plane at higher atmospheric temperatures, but they also need weight. So they would need to do the research to find out where is that good middle ground of material properties for this metal.
The metallurgical engineering has various subsections and is a subsection of material engineering with an emphasis on metals as well as incorporating aspects of industrial engineering, as you can see in plant management and the designing of processes to refine the metal and use it. But it can encompass almost any field of engineering that requires metal, including aerospace, civil, computer, mechanical, and electrical, to name a few. But really, anything that has metal in it, as Adam said before, some metallurgical engineer was involved with that piece of material at some point in the cycle. And that's it.
Thank you, guys. Great presentation. Yeah, I don't know as much about this field as I do about the others, but I think what's really interesting is that it's another field of material engineering, like you said, and it's very specific to metals. And if that's something you're really interested in, I just can't help get out of my mind this photo of extruding an I-beam coming out of something, you know, as you're processing that metal. It could be kind of fun. What got you guys interested in this?
I can go first. And for me, if I hadn't gone into engineering, I probably would have gotten into some type of metallurgy or metalworking, because I enjoy working with metal, the different types of possibilities that it can bring. And I also really like this field because it's very vast. There's a lot of stuff you can do with it. And one part that we didn't get to put into the presentation that I thought was cool is that computational engineers and AI engineers are very much involved with this, because when you're mass producing large amounts of metal, you need a automated process, like in how cars are assembled. But because it's hot metal and it's very tricky to work with, it's a difficult process that has to meld automated processes with human aspects as well. So I just kind of like that intricacy in it.
I was interested with this field because it's just, like as Adam said, it's just such a vast and varied field. With it, you could realistically work in just about any industry you wanted, assuming there's a demand for it.
That's true, yeah.
You can apply to just so many things. Like you could work in the production of cooking equipment or cars, or mining is the biggest example, but just about anything you can think of, there's probably someone in that industry who's a metallurgical engineer.
Very cool. And it's, if you really think about it, it's actually one of the oldest fields working with metals. Before we knew the science behind mixing metals and their cooling points and all of that. So very, very cool. Thank you guys so much. All right, next we have nanotech and then mechatronics, and we have literally 8 minutes left. So we need to go fast.
I think we can keep this quick.
Cool, thanks, Brandon.
Let me share it really quick. Okay, can we see all right?
Yep.
Awesome. So we did nanotechnology and engineering. It was me, Carlos, and Jason. Am I saying your name right? I'm sorry.
Yeah.
Okay, cool. So nanotech and nanoengineering is a very broad subject. Basically anything that can benefit from being worked on at the nanoscale can benefit from nanoengineering. And that can both apply to nanometers or something at a very, very minuscule area. I put a bunch of examples here, but basically materials at the nanoscale can be made, their physical and chemical properties can be changed. So they can be made stronger, lighter, more durable, more reactive, tolerate heat better, stuff like that. And when I post these later, I implore you to take a look because it's very vast.
for the technology industry. Affects a large number of sectors currently in development. And then, as you see in the list, we have information technology, homeland security, medicine, healthcare, transportation, energy, food safety, agriculture, and environmental science, and many more.
Nanotech engineers work on microscopical electronics, which means their environment would be, a science research facility filled with microscopes and small and computers, and sometimes even factories, since some would be working on manufacturing companies, and they'd have to be focused attention to detail on the materials they work on, and they'd also have to write large descriptive reports towards the end.
And then for the average annual salary in the United States, it's this thing's blocking it. $99,000 with $44. And then as offers type or as other types of engineering advances, the nanotechnology increases.
Yeah, that's about it for us.
Okay, great. And can you tell everybody what the measurement is for nano sizes when we talk about them in terms of meters?
Oh, definitely. It's as far as I'm concerned, it's nanometers, the nanoscale, or microns.
So it's nanometers, and how much is a nanometer in scientific notation? Do you guys know?
Let me find it out right now. It is 1 × 10.
No, you don't have to look it up
-9.
because it's exactly. So just in your mind, try and envision that size. That's what's really incredible. And this is another field that's rapidly emerging at the moment as we try and miniaturize things really for use inside the body and use inside computers. And I mean, just think of the phone example I gave you early on and how it was like a brick and it's gone down to this. That's downsizing those components. So lots of opportunities in the nanotechnology field. All right, let's hear from Mechatronics. Jose, Ruben, and Zane.
Oh, let me share screen.
Thank you.
Can you guys see?
Yep.
Okay, so Mechatronics. So some of the things they produce are things like 3D printers, robotic arms, electric hand tools, computers, and even robotic limbs. So you can, instead of having just like a prosthetic, it's just made out of plastic, you can actually have like working fingers. So that's pretty neat. And then robotic arms for like building stuff in factories, and 3D printers. You can see they made like a little dragon or something like that. And then
yeah, and what sectors they work in. Mechatronics is very broad. As you can see here, there's technology, telecommunications, manufacturing, defense, anything really. Anything that has circuitry in it and moves could be attributed to mechatronics. Next slide.
They typically work like in an office at a desk on a computer, using stuff like SolidWorks and stuff like that to design and build assemblies, or they're in labs and facilities. They also work in testing facilities to test their products to ensure that they work properly. And sometimes they even go inside other factories for troubleshooting, things that may have gone wrong with like a robotic arm or stuff like that.
Next up, we have the specialties. So this type of engineering is a combination of electrical, mechanical, and software engineering. You can see it in the bottom right picture. And so mechatronics engineers usually work in fields of cybersecurity, telecommunications, computer science, automotive engineering, robotics, artificial intelligence, and many others that we didn't list here. And this is very hands-on and works mostly on moving products.
Yeah, and here we have the average salary. It's quite high, 107,300. And the wages vary. There's a big disparity because it's such a broad field. as you can see, from 57,261. And I believe if you're interested in mechatronics, Chico has a degree. Otherwise, you're gonna kind of have to major in mechanical and get a minor in electrical or computer engineering or something like that. And here are some of the places where I guess you don't want to be: Nebraska, Puerto Rico, etc. And the highest paying: California, DC, and Alabama.
Alabama seems like an outlier there. Not sure.
It does.
Um,
Yes, it does. I
yeah,
believe
well, would you say that this is kind of a techie type thing? So where the
Yes.
tech is yeah.
I believe Alabama has it was a big aerospace program. I think that's why it's so high.
I also heard that in a few years, I think Monterey Bay is gonna offer a degree in this.
Yes, Monterey Bay, and I believe Cal Poly has one.
Okay, I see.
Yeah. So a couple options in California. Again, that's relatively new degree options. They just started. They said, oh, well, a lot of people are interested in this, and they go into mechanical or electrical, but we need to just combine them and create a mechatronics degree. So there may even be more degrees coming out in that, actually. Sorry, I kind of jumped in. Were you guys finished?
Yeah,
Yeah,
that
no worries.
pretty
We
much
were.
summed it up.
Okay, great. Thank you all. I hope that you got a really good overview of some of these fields. I think what you may have noticed as we went through this, you may have seen over and over again how many of these fall under our major fields that we know about: civil, mechanical, electrical, and they're actually a subset of those, or they combine those. And I hope that you saw that no matter what field of engineering you go into, you have opportunities in research or testing or design or development or manufacturing or construction. So the job function exists in many different fields of engineering. You don't have to go into manufacturing engineering to be working on manufacturing. You could go into metallurgy and be working on manufacturing. So find your passion in one of these fields, the major ones or the minor ones that we've talked about, and you'll find the function you want to do. If it's administration, you'll find your way into administration in that field. If it's design, you'll find the design component of that field. So find the thing that interests you most first, and that's what I hope this is highlighted. As I've mentioned throughout, there's some of these that we'll explore more, some of them that we won't, but if questions arise, I hope I've pointed out when they come up that you can ask about them. So mechatronics you can ask about during mechanical, which is with me, or electrical, which was with Carl. He'll be with you for electrical engineering, and he may have better insight than me even on that as well. Okay, so before we go, and I know class is over, there is a follow-up discussion post that each of you need to answer. And actually, one of you can do the discussion post for the rest of you. It's just one per group. It is the Obscure Engineering Fields discussion post, and it is due, oh shoot, I'm in the wrong place. It is due, I don't know, I can't find it now. If someone else is looking at it and can chime in, please do. And I'm going to add to that discussion post the sources. So make sure you add your sources in when you post there. Oh, okay, my computer is now working, so I can get to it. Okay, and it's due February 8th, which is Monday. Okay. The other thing I want to say is that we'll be talking about engineering design process next week. And for that, what I would like you to do is to make sure that you come to class having done a couple things before class. And I'm going to share my screen and just show you those. This is welcome to class 3. This again will be open at 9 p.m. tonight. There's the engineering design process is in chapter 2. I think you're reading chapter 2 this week. And I have a couple of videos that sort of introduce it, talk about a problem. And I've also posted 2 videos that where Joanne and I have had conversations with former students at Cabrillo, and they talk about aeronautical engineering and electrical engineering. And it's a nice way to watch them learn a little bit about those fields, as well as hear some advice from those students. And also see what it's like to have this interactive experience with a guest speaker, which we will have with Rob joining us next week for part of the class as well. So I hope we got everybody's talks in, right? I didn't miss anybody. I think I got everybody. Yeah, okay. So see you next week. It'll just be me next week. And let me know if you have any questions.
So Preeti, you just wanted us to watch those 2 videos. That's what you want us to do before next week, as long with getting the clay.
These 2 videos, and there's 2 more, one with Patrick and one with Megan. So there's 4 videos right here. Gotcha. Yeah, and right at the bottom, it says clay, coins, and water.
Great, thank you.
You're welcome.
Nice week.
You too.
Bye, everybody.
Bye.
Bye.
Have a nice week.
You too. Bye. Let me know if there are any questions. Okay. Oh, stop share. All right.